This session will see integration of LED with the help of switch. So, this is a program where you are going to learn what is the code, explanation of the code, connections and then the output. So, integration of LED along with switch, these are the connection parts, Raspberry Pi and then breadboard. You are connecting switch and the LED. So, we are writing this program. The previous program was only using just LED. We have write the program and then output was whether the LED is on or off. But here we are taking switch as an another sensor. Depending upon the input of the switch, the light will glow on and off. So, for that the program is import rpi.gpio as GPIO, importing RPI library into a Python code. Next, importing time. This we are importing the time library in order to use time.sleep method. Next, GPIO.set warnings false. So, this method it is optional, you can use it if you want. Whenever you are running the program, you are going to get some warnings in the output window. If you do not want to see that, you can use this method, it is optional. Next, GPIO.set mode, GPIO.BCM. Here you are selecting what is the numbering scheme that you are using. We are selecting BCM. Next, GPIO.setup 24, GPIO.out. So, output pin you are selecting as a 24th pin among the 40 pins of Raspberry Pi board. Next, GPIO.setup 23, GPIO.in. So, the input you are taking from 23rd pin, output you are getting it on 24th pin of Raspberry Pi board. Next, you are writing the while loop to which pin you are going to connect the LED and to which pin you are going to connect the switch. For that you are writing the while loop. In while loop we are telling GPIO.output 18, GPIO.input of 4. So, 18th pin we are connecting the LED. Next, time.sleep. For some time, waiting time where the LED is on, you are waiting and then LED is off. For that you are writing the method time.sleep. So, that is the program, and so this is the Protest 8 professional software where you can do the schematic diagram of the connections. So, here the previous program, same program we are writing using PWM pins of Raspberry Pi board. PWM represents pulse width modulation. So, pulse width modulation, it is going to take the analog signals. So, for that you are writing the same code, but here the difference is that using the pulse width modulation pins, you can increase the brightness of LED or decrease the brightness of the LED. So, for that you are writing the code import rpi.gpio as GPIO and then you are importing sleep library. LED pin is equal to 12. So, 12th pin is the PWM pin which takes pulse width modulation pin which is connected to LED. So, LED you are going to connect to 12th pin of Raspberry Pi board. Next, GPIO.set warnings false. In order to disable the warnings in the output window, you are using this method. Next, GPIO.set mode, GPIO.board. So, this is the numbering scheme that you are choosing to write the program. GPIO.setup LED pin, GPIO.out. So, you are going to get the output in the 12th pin, but LED pin here the value is taken from the 12th pin of Raspberry Pi board. Next, PI-PWM is equal to GPIO.PWM LED pin, 1000. So, this statement particularly we are using to create PWM instances with frequencies which helps to generate PWM signal. Okay, in order to generate PWM signal, we are using LED pin, 1000. We are creating the instances. Here you are connecting only one LED. You can try out this program connecting 3 LEDs like red color LED, yellow color, green color. So, these 3 colors you are first creating the instances of it. Why you are creating instances of it? In order to tell the initial state of the LED. So, initial state of the LED will be 0. That means it is neither on or it is neither off. So, it is just the starting stage where you can represent it as 0. From 0 you can increase the brightness or decrease the brightness. So, in the same way here we have taken only one LED pin. So, that is why we are creating the instance of that particular LED. And PI-PWM.start. So, here the duty cycle of PWM will start. So the duty cycle is the representation of analog signal in a square wave is called as duty cycle. So it will be 0 duty cycle, 25% duty cycle, 50%, 100%. This particular topic we have already explored the previous units. So just to refresh, I am telling here duty cycle means the square wave. Next, these two methods or the for loops you are writing inside the while loop in order to represent. First for loop represents the increasing the brightness of LED, second for loop represents decreasing the brightness of LED. So for that the code here we are writing for duty in range. So the parameters you are taking for this method duty in range is 0, 0 is the initial state of the LED, and from 0 you are incrementing one step every time till you are reaching 100. So from 0 to 100 you can increase the brightness. So for that you are writing the loop here, pi-pwm dot change duty cycle of duty. So here you are providing duty cycle in the range from 0 to 100. So whatever the value you are receiving, that means whenever you are pressing the push button, the input it is taken, what is the value it will be collected in that, and if it is in the range of 0 to 100, accordingly the brightness of the LED will be glowing. So that will happen using the sleep method. After 5 seconds it will be changing, the range will be changing depending upon the input it is taking from the switch. So you are pressing long press, you are just pressing depending upon that which is falling in the range 0 to 100, accordingly the brightness will increase. In the same way this for loop for duty in range, here we are starting from 0 because this loop we are writing for decreasing the brightness of LED. So that is why it will start, the initial value is equal to 100 and from there one step it will decrement until 0. So pi-pwm dot change duty cycle of duty, from 100 it will decrease, depending upon the value the brightness of the LED will be decreasing. So this is the output. Finally after collecting it, this is the stage where you have connected it, but the stage of LED is 0, value of PWM is 0. Next LED is on with PWM value in mid range, from 0 to 100 it is a mid range, so the brightness will be somewhat less. Next LED is on with when PWM pin is high, that is more brightness. If it is 100, the glow of the light will be more, brightness is more. So these are some of the screenshots of the program. Thank you.